All right. Session now being recorded. Happy Thursday. If you were joined relatively recently, we were just catching up on math, and that's where we're at. I'll answer one more question since it just came in on the chat. Favorite movie? It's kind of tough. Probably Lord of the Rings, The Fellowship of the Ring. I've watched it like an insane amount of times, and I just love that movie. It was something I saw when I was in like sixth grade, and it just kind of resonated with the remainder of my time. I haven't watched it in a long while, but yeah, definitely probably my favorite movie overall in my lifetime. Not necessarily the best movie I've ever seen, in my opinion, but like my favorite movie, if you can kind of differentiate the two. That's a great question, Sarah. But yeah, right on. So we are now about to jump into math. We're in lesson 14, yada, yada, yada. We'll see what that's all about after we go through our agenda today. So this is Spirit Week number 2. We talked a little bit about this on Tuesday. Mentioned I didn't do Mellow Monday, but TikTok Tuesday, I don't have a TikTok, so I didn't do that. Wilderness Wednesday, I actually posted a picture of my pup yesterday evening on the Google Classroom, so you can feel free to check that out. Hopefully y'all been able to get outside. It sounds like Andrew, you've at least been since got a new lawnmower and mowing the lawn. So hopefully the rest of y'all are getting outside and enjoying the nice weather. Maybe in the mornings and evenings because it's already getting crazy hot. Kind of skipped that beautiful weather portion almost from rain to heat. But yeah, Throwback Thursday, soon to come on that actually. I think one of the next slides, I have a couple pictures of me from my high school days. And tomorrow is Feel Good Friday. So if you happen to be tomorrow our office hours, keep in mind that they're now available to be seen virtually via Zoom at 10 a.m. I am here from 10 to 11 on Zoom to talk, hang out, and or help you with anything you need help with. We can talk about Feel Good Friday then. If not, I'll put a little blurb, one of those little short videos that I've been trying to put out each Monday and Friday, and say shout y'all out. But that's our virtual Spirit Week. Quickly, darn it, accidentally went too far there. Just reiterating, meaning repeating our announcements that we mentioned on Tuesday. Y'all have been working hard. For the most part, the people that are in this session right now, since y'all are here, I'm speaking to you. I've seen the fruits of your efforts show up. You've been working hard. I've seen a lot of good work, not only being turned in regularly, but also turned in correctly. So that's awesome. Just want to continue to encourage you to keep showing up and keep working hard. And if you ever need anything, let me know. I know you have an abundance of other classes with other work. So if you need accommodations or help from me, or just some recommendations or anything, just let me know. I'd never hesitate to answer that. And they're going. We posted a new one actually this morning. It's on factoring, which we're going to talk about in today's lesson. Keep working hard on that factoring. It's a super important lesson, but get those ed puzzles done. I have due dates on there, but keep in mind old ed puzzles. Even the first ones that we posted, you can still complete them if you haven't. So feel free to go back and get those done. The remote learning agenda, the RLQs, keep using them. One of you all posted on RLQ this morning, so great job posting for that question. Heads up, that student asked for some homework help. I'm going to get those homework answers recorded either on this session or in separate YouTube videos this afternoon. So check in on that YouTube channel to get some lesson 14 homework answers done. Shout out to the student who asked that. What you see on the screen in front of you is the remote learning agenda. Gives you everything that we're doing each and every class and the assignments. It's basically our pacing guide. It's our agenda rather than me standing up in front of the class every day at the whiteboard and being like, hey, we're doing this today. This is kind of just our full document that tells us what we're doing when we're doing it. And last but not least, extra Zoom session. We already talked about it tomorrow at 10. All right, where were we? Okay, cool. So this is my little throwback Thursday. Pictures of me in high school, top left at a Dodger game, bottom right at my graduation. I went to Saugus, so that's hence the Saugus colors. There's some of my friends I was Zooming with them last weekend or 2 weekends ago, and they sent these pictures, so it made it really easy for me to go back and find pictures rather than digging through the archives of a flashback. So these are little throwback pictures of moi from my high school days. And without any further ado, what are we doing today, you might be asking? Lesson 14, wrapping it up, continuing to factor polynomials through the looking for GCFs and then using that X tactic, first times the last, that factors them into the middle to factor by grouping. That's where we're trending. We have 2 problems that I want to finish before we do so. It looks like, there you go. Sorry, my screen froze. So as I was talking, basically what I was trying to get to was we're going to wrap up lesson 14 with what you could see page 562, numbers 15 and 21. So that's where we're trending. So if you have your text out in front of you or a blank piece of paper for notes, let's cruise into page 562, numbers 15 and 21. Boom. Okay. All that I'm trying to do here is factor. I'm not trying to solve anything. What we're actually doing and have been doing over the last week is learning how to factor so that we can combine it with lesson 11, the zero product property, and start to really solve these quadratics super efficiently and effectively with factoring. But we're not even asked to solve this now. We're just trying to factor. So number 15, page 562, here we go. First thing we always look for, always, no, we're not going to do number 13 just for sake of time, just kind of transcending or moving on to 15 there. But first thing that we're always trying to do when we're factoring is look for commonalities, what we call GCFs, okay? We always look for this in math, and realistically, this is actually an extension of something that we do without even thinking about it in life. Typically, when you're trying to group up or become friends or just even understand the world around you, you look for commonalities, okay? And what I mean by that is you're trying to understand a situation, whether it be a class, a hobby, you look to try to build your understanding off of something you've already experienced, okay? You walk into a new room, you observe what's going on in the room, and you adjust to it. Same thing with friends. You group up with friends who have common interests or same thing, they like the same thing as you. So we do the same thing in math, it just doesn't seem as natural. And that's what we're doing when we look for GCFs. We say, okay, do all of these terms have something in common? And if so, can we take it out to make it more simple, okay? And in this case, when we look for a GCF, GCF stands for greatest common factor. That word common means everything has to have it. And we quickly see here that all three of these terms, x squared, negative 7x, and 6, do not have something common amongst all three. Now, the first two terms in our trinomial, the x squared and the negative 7x, obviously have something in common. They got x's. But the last term does not. So that's not a commonality. And sometimes these last two numbers could have something in common. In this case, they don't, other than one. Long story short, no GCFs. Our primary form of factoring kind of struck out on that one today. So what we've learned over the last few classes, basically last Thursday, this Tuesday, and today, is something that we call factoring by grouping, specifically using what's called the X chart. Now I want to mention that the X actually has nothing to do with the fact that these variables are X, okay? The X chart is only called an X chart because it looks like the letter X. And when we're trying to solve with the X chart, what we're doing is we are using the numbers on the bookends, the first and the last, the A and the C, if we think about it in standard quadratic form, flashback to that Edpuzzle, identify the A, B, and C. In standard quadratic form means the numbers in front of the variables, or just the regular numbers. So in this case, my A is my leading coefficient, or my first number, and that number is 1. And my C is 6. So when we're using an X chart, we populate the top with the product of the first times the last. 1 times 6. And what is 1 times 6? 6. All right. Then we move the B value on down to the bottom. So the B value is the number in the middle. B comes between A and C. Nice little connection back to our first grade knowledge of the alphabet. But the B value is just the number in the middle. And keep in mind that that is a negative 7 because the minus sign implies negative. So our B value, our bottom of our X, gets populated with that. Product of the first two, first times last, 1 times 6, boom, kind of color coded in red there. Bottom of our X is the purple. Now, the big step here that was kind of weird at first, and maybe weird if you haven't been in the last few classes, but this is kind of the step here. We populate the other sides of the X, the left side and the right side following. We look for the factors of our top, numbers that multiply to give us 6, that are going to add up to the bottom, negative 7. So we're trying to find factors of 6 that specifically add up to negative 7. And does anyone think they know potentially a factor of, or factors of 6 that could add up to a negative number? 6 and 1, 6 times 1 does give us 6, but if we add up 6 plus 1, does it give us negative 7? No. But you're right on it, man. Those are the numbers. But instead of a positive 6, it would be a negative 6. And instead of a positive 1, it would be a negative 1. Because after all, 6 times negative 1, great job, dude. 6 times -1 does give us 6, and 6 plus -1 does give us -7. Now, the whole point of us doing this isn't to practice multiplication and addition, but rather to allow us to expand this trinomial. And what I mean now is I'm going to flash back over here to the actual equation, okay? Let me get rid of all this unnecessary stuff. The whole point of this is to take this equation, x squared minus 7x plus 6, realizing we can't factor it in its current form, and say, all right, I want to try to break it down and narrow my focus, factor by grouping. But we can't make even groups because we only have 3 terms. And even means something that's divisible by 2, and 3 terms is an odd amount of numbers. So we have to basically expand this middle term. And guess what? We have the numbers to allow us to do so. Of 6 that added up to -7 were -6 and -1. So the step is, once we know those side numbers, -6 and -1, those factors, all we do is we basically say, all right, expand that middle term. And the reason why we now have expanded this middle term is because as I zoom in on my new polynomial, which is, by the way, the same thing, just unsimplified, we have the ability to make those groups mean 2 groups of 2. Now we have an even number of terms, 4 terms, 1 term, 2 term, 3 term, 4 term, and then we can factor by grouping. Does the order in which you write the final answer matter? Nope, that's a great question, Ashley. Commutative property says the order in which we multiply does not matter, so it does not matter, but that's a great question. And we'll kind of tackle more on what she's asking there in just 1 second, y'all. So what we've now done is we have narrowed our focus. Kind of like I said, when we enter a room, we focus on things that are weird to us and we try to figure out how to adjust to them. And we are now focusing on a weird polynomial, and we expanded this middle term to focus on a much smaller set of numbers. So grouping symbols, parentheses is the most common one. We use that here. And now we can focus on each group individually, meaning what can we take out of both these two terms? The GCF idea, the greatest common factor. Andrew already told us. He basically said the following. You can take an x out of both of those terms because they both have an x. So he extracted or took out the x via division. X squared divided by x is just regular x. Sorry about that, let me get my colors right. And if you legitimately take the x out of -6x, all you're left with is -6, which is why if you look at the chat box, what you see from Andrew's most recent answer is x times x minus 6. He factored out from the first group. Now we're going to rinse and repeat, meaning do the same process again. Looking at my second group of 2, what can I take out of both of these terms? And this might be a little difficult to do, so I always follow this shortcut. Once I know my first parenthesis, to make this process work, the parentheses have to be identical. So I basically just copy it right over there. And now it's easier for my eyes to associate what needs to be taken out. What do I need to take out of 1x to make it just the x? And what do I need to take out of a +6 to make it a -6? The number is the same for both. What can I take out of both a -1x and a +6 to make it into x minus 6? And the answer to that is, you literally just take out the -1. Great call, Andrew and L. Yeah, you take out the -1, boom, you're left with just the x. You divide 6 by -1, -6. So that's why I try to just kind of copy the parentheses first, because it makes finding the GCF a little bit more straightforward in my opinion. But here's the final kicker. Now that we are at this point, which I'm circling, okay, we expanded our polynomial, we made 2 groups of 2 terms, we factored out the GCF shown in blue. Now all we have to do is use the distributive property, but in a weird kind of backwards way. The property basically says you can distribute or make multiplication combinations, but I'm going to do that in reverse. Since both x and -1, where did I get those from? The GCFs that we just found. Since both x and -1 are being multiplied by the same thing, x minus 6, we can combine the 2 multiples as such. And this basically now revisits Ashley's original question. Does it matter which order we write these 2 parentheses here? No. It could be x minus 6 times x minus 1. All is fair game. They are the same thing because of the commutative property, just like 4 times 3 is the same thing as 3 times 4. Order of multiplication doesn't change our outcome. and Andrew's factored form is correct. What we now have, y'all, is the answer. A quick check says we're supposed to be multiplying here. Notice no operation sign in between. So if we FOILed or used the distributive property, we should get right back to where we started. X times x is x squared. X times -6 is -6x. -1 times x is -1x. And -1 times -1 is +6. That's what we did about a week and a half ago, really building on that knowledge of multiplication, combinations, distribution. And sure enough, take a look at what this is. It's where we expanded the polynomial from the jump to factor. And if we combine these like terms, these two regular x's, -1 and -6 combine to make -7x, which is the original polynomial itself. So what we're doing right now is learning how to factor. So then that way, if I said, hey, good luck, solve this problem, you'd have the ability to. Because what we've now just learned is that we could factor down this right side by doing that X tactic. And now it's an easier problem because what we've done is we've turned a multiplication problem or something into a multiplication problem, parenthesis times parenthesis, that's equal to 0. And that's the best multiplication problem we've ever talked about because the zero product property states if you ever have a multiplication problem that's equal to 0, just set both factors equal to 0. Whoa, I don't know what happened. Sorry, I hit the wrong thing. Just set both factors equal to 0 and solve. And that's really the whole point of learning how to factor, is to make solving for things with a power of 2 simple by factoring and setting them equal to 0. It's kind of the end game, which we'll see next week. But I want to get a little bit more practice before we jump too deep into that level of understanding. Let's try number 21 here. Okay. There's our answer for 15. 21, x squared plus 2x minus 8. First question we got to ask ourselves, first thing we always look for with factoring, I don't want to gloss over this, is there a GCF? Let's check. Well, there's definitely a GCF between the first two terms, but does this one have an x? No. So no GCF of a variable. There's definitely a number I could take out of both 2 and -8, but keep in mind, y'all, that this 2 up here is an exponent, not a number, not a regular coefficient. So no GCFs. So what do I do when I have 3 terms? I try to make it into 4 terms. And how do I do so? X tactic, boom, boom. X tactic is a big old X chart. What gets populated in the top? What goes right up here? The first number times the last number. Keep in mind, y'all, that every single time I say this, I'm repeating it for when the problems get harder. When the number in front isn't visible, it's 1. It's really just the last number. So first number 1 times last number is -8. What goes on down here at the bottom of my X? My B value, my middle value in between the A and the C, and that number is a +2, aka a +2. And now we answer the question, the factors of -8 that add up to +2 are what? Oops, sorry, that's supposed to be a highlighter. What are the factors of -8 that add up to +2? AJ, great job. L, you're right there to switch those signs. It's going to be a -2 and a +4. Yeah, great call, y'all. Because -2 times +4 gives us a product of -8 factors. And -2 plus 4 adds it to +2 because the 4 is bigger and it's a positive. So what we've now just done, y'all, is we have created the ability to rewrite this trinomial, 1, 2, 3 terms, A, B, C, into 4 terms. So we can make 2 groups of 2. So here we go. Let's rewrite it. We have y equals x squared plus 2x minus 8. But notice I skipped 2x because I'm going to rewrite that 2x in an expansive or bigger way by using my numbers that y'all just gave me. -2x and +4x. Sweet. Now we factor by grouping. What is a grouping symbol? The most common grouping symbol is a parenthesis. So we do parentheses around my first 2 terms, parentheses around my second 2 terms. Notice I put my plus sign in there to remind me that it's a +4x. And now we get to business. We always try to factor by GCFs. Now that we've made 2 groups of 2 terms, we look for GCFs, aka what can I take out of my first group? When we group, we narrow our focus. So it's like, all right, cool. I'll have to find GCF of two things now. What can I take out of these two things? What do they both have in common? No doubt, Andrew. An X. Look at. Probably like, yeah, I see it. They both have X's. Right on. Let's do it. So when you take an X squared and you take out an X, here's what's really happening. X squared is the same thing as X times X. Those are the same things, equivalent. And when you simplify, aka divide, what you're really doing is you're removing common factors. So all we're left with is just a regular old X there, because we took out one of the X's. Well, legitimately, a little bit easier, I think, for my eyes to see, when you got a negative 2x and you legit take out the x, what are you left with? Just negative 2. Cool. Now, here's the shortcut. I know for this to work, the parentheses have to be the same. So boom, boom, boom. I'm just going to copy it right over there. Now, it might make it easier for me to see exactly what I got to take out, meaning, what can I take out of 4x to make it a regular x? Well, that's pretty easy. Just the 4. The 4's got to go, and it's a positive 4. And does this still hold true? If you divide negative 8 by 4, do you get negative 2? Sure do, which is why Andrew wrote down in the chat box 4 times x plus x minus 2. Now here's the final step. We now know the reverse distributive property says the following. We could take the individual GCFs shown in red, x and positive 4, and we stack them together. Why? Because essentially the logic that's going on here is the following. X has an x minus 2 and 4 has an x minus 2. It would be like walking into a room and realizing that someone that you didn't know previously has the same exact favorite hobby as you do, and being like, oh cool, we should hang out. And that's what x and 4 are doing. They're hanging out. They said, all right, we both have x minus 2 in common. Let's group up and talk about it. Well, x and 4 both have x minus 2 in common, so they group up and they still have x minus 2 there with them. And guess what? We have our factored 4. All right. Super step-based in the beginning. Very kind of like weird and different. It's using factoring as we've learned it both in elementary and junior high levels, and even any other math class, regardless of when you learned it. It's using old school factoring concepts, GCFs, but it's basically realizing from the jump that we can't do that first. So we expand the polynomial. Really, we do this first. We make that 2x into numbers that multiply to the first and the last and add it to the middle. We expand it, narrow our focus in on 2 groups of 2, and then we use GCFs at that point. Cool. So that's really it for today's lesson. Let's do a homework problem. All right, let's do page 565, number 2. Okay, I think it's the first homework problem if my memory serves. Keep in mind, y'all, that the pacing guide for this class, this thing says we should have been doing lesson 15 today. Since I get to run this class, I'm going to say, you know what, we're going to push that back to next Tuesday, okay? So lesson 15, theoretically, realistically, is the same exact thing as this whole lesson, FYI. So if you understand the factoring that we just did and that we'll continue doing for about the next 10 minutes on the lesson 14 homework, you can actually go do lesson 15 homework too. It is legitimately the same thing, just with maybe a different number than 1 in front, okay? But if you are like, what in the world is this guy talking about? No stress, we'll do lesson 15 on Tuesday. I'll just adjust the pacing of this class, okay? All right, I digress. I get off on a different topic. Let's get back to page 565, number 2. In this problem, we want to write the factored form of this equation. Cool, I don't care about solving it. Notice nowhere in this directions does it say anywhere to solve. Right on. So what we're gonna do is we're gonna write the factored form of this equation. First thing we always do is look for a GCF. Hey, those both have x's. This one doesn't. Okay, hey, 8 and 12 can both have 4 taken out of it, but guess what? That doesn't have a number, so GCFs are out of the mix. You can probably assume that that's going to be the case for every single problem on this one. So what do we do next? We make our X chart. Cool. We already talked in depth about what this whole thing is about, so I'll kind of spare y'all on that, but I'll still continue to repeat the process of how we fill out the X chart. Top is the first number times the last number. 1 times 12 is 12. Okay. Bottom number is the middle term, the b value in our quadratic standard form, a, b, c, and our b value, our middle number, is 8. Cool. What's going to go on the sides? The factors of 12. The factors of 12 that would add up to 8. Let's just do this here. What factors of 12 would add up to 8? 6 and 2. Awesome. Great call, Andrew. Boom, boom. Let's drop them in. It does not matter the order in which you put 6 and 2. That was Ashley's original question, kind of viewed from earlier in the process. It could be 2 and 6. I just wrote 6 and 2 because that's the first thing that I saw from one of y'all's answers. So now, basically, in my opinion, the hard part is kind of done because now it's just grouping and factoring from GCFs. So let's expand this polynomial. Notice again, I left that middle blank. The reason why I left that middle blank is because that 8x is no longer going to be an 8x. We are going to expand it into the numbers that you always gave me, a positive 6x and a positive 2x. The purpose of which is to factor by grouping. Group 1, boom, boom. Group 2, grouping symbols, grouping. 2 terms, term 1, term 2, term 1, term 2, and both, it's even groups at the very least. Now we look for GCFs. Just copy this down. What can I take out of my first group? What do both of these things have in common? An x. And when you take an x out of an x squared, you always just have an x left. Boom, boom. When you take the x out of 6x, you're just left with the number, the coefficient 6. What can I take out of the next group? Maybe hard to see, so guess what? Shortcut. Make those parentheses the same. Now it might be easier for us to identify. What can I take out of 2x to turn it into a regular x? Well, I got to just take out that number, 2. Now let's check to see if this holds true for both terms. What is 12 divided by 2? 6. Chill. Okay. Now, since both x and 2 have the same thing in common, that same thing in common is x plus 6, the distributive property says, hey, why don't you group up x and 2? Kind of like when you're a little kid and like you go somewhere for like a birthday party and then your mom's like, hey, you and that other kid have so much in common, you should hang out. Well, we're forcing you to hang out right now because x and 2 had something in common, so we combine them because they had x plus 6 in common. Right on. Ridiculous analogies, but maybe it works. So we have now officially factored number 2 on page 565. All right, that should do number 2 as I zoom out slowly to kind of buy time for y'all to write down that problem. We will then move on to number 8. All right, let me take a little time here, stretch out my forearms. Let's move on to number 8. All right, same direction, same process, don't care about solving. After all, we kind of talked about before we went remote, it's hard to solve an equation with 2 variables, x's and y's, because there could be infinite solutions. After all, solutions to a 2-variable equation are an ordered pair. And we know quadratics can go on forever, meaning all these points that make up a quadratic are solutions. Therefore, there's theoretically an infinite number of answers unless we zoom in on one specific answer, which, flashback to the first unit on this when we were learning about graphs, is the roots. And that's where we're going to trend next week, is being like, oh, we're looking for where x's have hit the x-axis, where the problem hits the x-axis, aka where y is equal to 0. That's what we're next week. That's why we're learning how to factor, to use the 0 product property. It all kind of comes full circle. But again, I get ahead of ourselves. They're not asking us right now. They're asking us just simply to factor. What do we always look for first? GCFs. Is there a GCF amongst all 3 terms? Nope. Not x's. Numbers? Nope. So what do we do then? X chart. How do we fill out the X chart? First number 1 times last number 14 goes to the top. So how do I get that again? 1 times 14 give us 14. C, a miscellaneous work. What goes in the bottom? The middle number. Keep in mind, that is a -9. So I'm going to make sure that I represent that being a -9 because that changes the game if you put +9. Look at the operation sign. It tells you whether it's positive or negative. Cool. So we now have the ability to say, all right, what are the factors of 14? I'll write this out so I can change my numbers out last. What are the factors of 14 that add up to -9? Does any brave soul think they know the answer to that? Factors of positive 14 that add up to -9. Nice, Ava, good job. -7 times -2 is positive 14, and sure enough, -7 times -2 adds up to -9. Good job. So we now have the ability to expand this trinomial. And we're going to do so right here. It's all right. Y equals x squared plus 14. Hey, why'd I leave out that 9x? Because that 9x doesn't matter to us anymore. It's now a -7x and a -2x expansive. Cool. So what we now can do is group and flash back to the thing that we want to do first, find a GCF. It's always the way that we simplify fractions. It's kind of ingrained in our brain. We just may not have known it at first, but it's really what it means to factor out. We always look at commonalities. What can I take out of both these things? Well, the only thing that this first two terms have in common is that they both have an x, so let's take it out. Right on. Cool. And y'all probably caught on to the fact that anytime you take an x out of an x squared, you get a regular x, and every time you take the x out of -7, in this case, you just get -7. Great call, Mia. X was our GCF. Cool. What can I take out of both of these two terms? I'm going to forego the shortcut. Great call, Andrew. -2. Because theoretically, even though this is 14, y'all know you can still divide it by -2. That was our factor, by the way. But also, another way that we could decipher that is say, all right, we want the parentheses to be the same. So just copy and paste over here. And then you got to figure out, oh, what can I take out of -2x to make it just an x? Oh, then the -2. Again, that's just kind of two different ways of approaching that idea of a GCF. Now comes the final step. Combine the red things, the GCF, the x and the -2, the x and the -2. Boom, boom. And what gets stacked next to them? The common parentheses, x minus 7, money. Okay, let's talk about a shortcut. And this works on every single problem in this lesson. The shortcut is as following. If there is a 1 in front, meaning if there is no number visible in front, notice all the things that I'm highlighting are the front numbers. The thing in front of the x squared, the thing in front of the variable squared, are a value. If your a value is 1, 100% of the time, these two numbers right here being circled in black, 100% of the time, if the a value is 1, become the numbers in your variable, in your factored form. It's a shortcut, okay? Works 100% of the time, every time if you get the right numbers. So, is my a value 1 here? Yep. What were my numbers? 6 and 2? Chill, 6 and 2, okay? You could always do that. So like theoretically, if I wanted to do number 6 real quick, all right, what are the factors of 8 that add to 6 and 2? I know the answer to this problem right now is x with a +4 and x with a +2. Okay, that's again figuring out process. It's kind of seeing patterns here, which is a very strong skill that humans do create through the form of mathematics. So it's kind of how we train our brain, so to speak, in that process. We see a pattern now that anytime this number in front is a 1, aka not visible, once you find the factors of the last number that add up to the middle, it will inherently be in the factored form. Okay, that changes when the number is not a 1, like in lesson 15. Sorry, wrong thing there. In lesson 15, if you're looking at this one, you got to go through the whole process, okay, because this number isn't a 1. But we'll talk more in depth about that on Tuesday. All right, that actually takes us right, which is awesome timing. So that pretty much wraps up our serious in-depth lesson on factoring. So I do appreciate y'all being here. For those of you who've been here throughout the last 3 lessons, there's a reason I spent 3 lessons and realistically next Tuesday 4 lessons on factoring. It's because it's kind of one of the hardest things to do, and it has extremely important ramifications in Algebra 2 trig. But it also is one of the more difficult things in Algebra 1. So I wanted to spend a lot of time going on this. It kind of stinks that the hardest tactics, the hardest things of the whole class kind of fell in a time where we weren't face-to-face, craziness that is this remote learning. But I do appreciate, long story short, y'all coming in and working hard continuously. So on that note, if you have any questions, feel free to stick around. If not, I do appreciate your time and effort here today. and I'll either see you tomorrow or I'll see you on Tuesday, okay? So thank you all for stopping through. I do appreciate it. Stick around with questions. If not, have a great rest of your day, y'all.
See you, Mr. Benham.
See ya. Bye, Sarah. Thank you. Bye, Nathan. Bye, Mia. Thank you. I appreciate y'all stopping by. By the way, I'm gonna do number 13, I think, because one of the people in here wanted to see number 13 done. So check that out. I'm also gonna record it. So if you need to take off, by all means. Cool. All right, I'm gonna end this recording right now, and I'm actually probably gonna start a new one for number 13.